Well, in our last lesson, we looked at simplifying roots, and those roots worked out nice, so our final answer had no roots left in them. What we're going to look at today is basically what happens when it doesn't work out quite as nice. Well, when you're simplifying roots, you want to make sure you don't leave any roots in the denominator. You don't want to leave any fractions inside of a root, and anything that can be taken out of your root, you want to be taken out. Well, let's go ahead and look at this. We need to simplify. It's a square root, and you know 25 is 5 squared. A to the fourth is an a squared times an a squared, because remember, you got to add your exponents. And a b to the ninth, so it's a b squared, a b squared, a b squared, a b squared, which is a b to the eighth, so you're going to have an additional b hanging around. Now, your square root here undoes each one of your squares. So your square root undoes a square in the 5. Your square root undoes each one of your squares on your a's, and your square root does each one of your undoes each one of the squares on the b's that are squared. However, we did not have a square on this b here. So there's nothing we can do with that b. So that b has to still stay underneath your square root. And now our a times a is our a squared, and our b times b times b times b is b to the fourth. Now, there's nothing wrong with leaving a variable or even a number inside of your root if there's nothing you can do to it. Same idea over here. 16, you know, is 4 squared, x squared, and then you'd have x squared, or y squared, y squared, y squared, y squared, y squared, an additional y. Now your square root undoes each one of your squaring here, but keep in mind that your last y does not have anything squared on it. So your square root undoes each one of your squares, but this last y with no y squared on it has to stay inside of your root, and so you end up just getting this when you simplify what's in front. Well, here you end up having a fraction inside of a root, and you never want to leave a fraction inside of a root. Also, we have a 9. It's easiest to think of 9 as being a 3 squared. It's going to help us because that means we can work with smaller numbers. So I'm going to start off by applying my cube root to the top of my fraction and to the bottom of the fraction, and we have this. Now, currently we have a root in the bottom. There's nothing we can do to take out of it. We don't want to leave that there. We want to somehow go from this down to this bottom one here where we have no roots left in the bottom. Well, to get no roots left in the bottom, we know that we have to have a 3 cubed and an x cubed on the inside here so that your cube root can undo those cubings. So really what we have to do is we have to think, okay, we got to multiply by something. And the only thing we can multiply by math and not change our answer is 1. So we need to multiply by a special form of 1. Well, we know it's going to be a cube root because we're dealing with a cube root times a cube root to give us our cube root. But then you got to think, okay, 3 squared times what gives me 3 cubed? Well, that would just be a 3 to the first power. And then you got to think, okay, an x times what gives me an x cubed? And well, that would just be an x squared. So this is our special form of 1. So you multiply the bottom out, and when you're multiplying roots, your root stays the same, and you just multiply what's inside, which we have right here. Same idea on top. It's still going to be a cube root. Multiply what's inside, the 2 and the 3, and you then have your x squared. The bottom, your cube root, undoes your cubing, so you have what we were showing here. And in this case, there's nothing we can do to simplify the top. So this top just stays there. Notice your exponent here on the x is smaller than your index in front, so you can't do anything. And 6 is not a perfect square, and it has no factors that are perfect squares, because the only factors of 6 are 2 and 3, and none of them are perfect squares. So let's take a look at this one here. We have a fraction inside of a root, so we want to apply the root to the top and the bottom. In this case, we can simplify the roots just like we were doing on the previous problem, or our previous slide, I should say. This is an x squared times an x, and the bottom would be a y squared times a y squared times a y squared times a y. So the top, your square root here undoes your square on the x squared, so you get an x in front of your root. But this last x was to the first power, can't do anything with it with the root, so it stays there. Your y squareds here are undone by the root, and so you get a y cubed, but then you have a y to the first, nothing you can do to it. So we no longer have a fraction inside of a root, but we still have a root in the bottom. Now, we want to eliminate that root in the bottom. We want to try to get to this, because we want to have the square root of a y squared, because you know your square root will undo that squaring, leaving you with just a y, still with your y cubed in front. So you got to think, okay, my square root of y times what gives me the square root of y squared? Or you can think y times what gives me y squared? Well, that's just a y. So you're going to have a root y and a root y. It's a root because you're dealing with a root y here. So you multiply the bottoms, you get this. So you multiply the tops. You're going to still have an x in front, multiply what's inside of your roots together. The bottom simplifies down to this. A y cubed times your y is a y to the fourth. Notice there's nothing we can do to simplify the top because it's an x to the first and a y to the first. So here we have a cube root of a root again. So apply the root to the top and the bottom. Now, in this case, there's nothing you can do to the bottom. It's a cube root. So you want to eventually get to this right here, because your index you have in front tells you the powers, the exponents you need to try to have on the inside. Because you know your cube root will undo those cubings, leaving you with this. And that's what we're trying to get to, because you don't want to have any roots left in the bottom. So you got to think, okay, a 3 times what gives me a 3 cubed? And well, that's just a 3 squared. Or an a times what is an a cubed? And well, that's just an a squared. So this is our special form of 1. We multiply the bottom by that, so you got to multiply the top by that. So you multiply the top, multiply your roots together. 18 is a 2 times a 9, and 9 is 3 squared, but we're dealing with a cube root, not a square root, so there's really nothing we can do to simplify the top. Now, roots can be added and subtracted if the number inside of your root is the same. So 3 of these root 5s plus 7 more of the root 5s gives you a total of 10 of the root 5s. Just like 3 oranges plus 7 oranges is a total of 10 oranges. The root in this case is kind of like your label. However, when you're multiplying roots together, the roots need to be the same, like both square roots or both cube roots, something like that. All you have to do is you multiply the numbers in front, the 3 and the 4, and multiply what's inside of your roots, the 5 and the 7. So your 3 and your 4 is your 12, your 5 and your 7 is 55. So once again, in multiplying roots, you multiply what's in front, and then you multiply what's inside.